Hello, Hiroshi. Are you around?
Yeah, well, I'm ready.
Ah, good. Good to see you. Thank you
Yeah,
for
good to see
joining.
you. So long time no see.
Long
How are
time
you?
no see. Do you want to try your screen share?
Yes. Well, just a moment. Which one? Which one? Well, I cannot find that. Oh yes. Well, it was strange. Just a moment. Oh yes. It's wrong. It's wrong. Not there. Oh, wait, this one. Can you see?
Yes, everything working fine. So this is perfect.
Okay.
Okay, yeah, thank you.
It's the
So,
slideshow. Sorry, that I forget to press the button of sound. Yes, I wanna share that again. Okay. All right.
okay.
I'm ready.
Yeah, perfect. Yeah, thank you. So it's 11 a.m. GMT. So let's get started the very last session of this workshop. And I'm very happy to have a Professor Hiroshi Ishiguro from Osaka University join this workshop as the final plenary speaker. I don't think we need an introduction of him, but very briefly, from my point of view, Hiroshi is one of the most distinguished researcher in the topic of communication, social aspects of embodied intelligence. And I'm very happy to have you here especially because we have all this remote form of interaction happening right now in the last year or so. And we understand more about what you're talking about, how robots play important role in our remote setting and telepresence and the communication in a different world. So I think this is a really good opportunity to learn from you once again what's the social aspects of our intelligence. So without further ado, I think I just hand over to Hiroshi for the plenary lecture. And if you have any questions or comments, please do post your questions and comments in the Discord where we can pick up your questions. Okay, Hiroshi, the floor is yours.
Yeah, thank you. Thank you, Fumi, this very kind invitations, and this is my great pleasure to talk in this the wonderful workshop. And I have one question. How much time do I have for the presentation?
So we have 45 minutes for this session. So yeah, feel free to use this time.
Maybe the 40 minutes and I will talk. So anyway, again, thank you very much. So my title is a constructive approach for interactive robots and the fundamental issues. Okay, so I'm a professor of Osaka University and the visiting director of ATR Hiroshi Ishiguro Laboratories. And this is my old project, JST Erato. But this project is already finished, and then I have started a new project, the Moonshot project. It is one of the biggest scientific the R&D project in Japan. I'm going to talk about that, and in addition to that, I'm thematic director of World Expo 2025 in Osaka. So I'm also talking about that a little bit. Okay. So, and this is my imagination. So, I think the near future it's quite important to realize this kind of a human robot symbiotic society, especially in Japan. So, in Japan, our population is going down to the half of our current populations within 50 years, and therefore we need to use more robots. And this picture shows that how the robot can help our daily activities. Okay, so in order to realize this kind of human-robot symbiotic society, 20 years ago, I have started my project for the interactive robots and the very human-like robot Android. Okay, and I have started my project with this mechanical looking robot. It's called the RoboBees, and then I have developed the robot like robot, and I have developed the myself my robot, my copy. So um, the first question, the first and important question is why do we need humanoid robots? So the answer is, I think it's rather simple. And the human has a brain that recognizes humans, and the ideal interface for the human is a human. Right? Therefore, the information media devices such as talking rice cooker, the Japanese rice cookers always talking, right? And should be at least partially human-like. And conversely, to understand humans, very human-like robot androids are needed. Right? So, um, based on that fact, that we are trying to develop the human-like robot and trying to understand humans by using that robot. That approach is called constructive science, a constructive approach with intelligent systems. The past brain studies have found that the human intelligence comprises elements of memory, the computation, the inference, and learning, etc. So the challenge is to identify how these elements can be put together for realizing human intelligence. So the constructive approach will reconstruct robots and androids to model humans and use such robots and androids to study the human macro level or meta level the cognitive functions. So if I simply say we are developing the human-like robot based on our experience and based on the knowledge from cognitive science and neuroscience, and of course the mechanical engineering, and by and and if we could see some the human-like phenomena, I mean, if it looks like intelligent, it looks like to have emotions. Okay, so we can deeply study about the intelligence and emotions by using that robot. So this kind of approach with intelligent robot, intelligent system is called constructive science, constructive approach. So, so far in robotics, we have focusing on these fundamental the issues, mechanics and manipulators and sensors, image understanding and voice recognitions. So thanks to the deep learning, we could reach to the human level performance for the image understanding. It is not perfect understanding. It's indexing, right? So and in the voice recognition, this is also the analog voice data conversion from the analog voice data to the text, right? But after this, we need to focus on the meta-level cognitive functions such as the intelligence, the embodiment, and multimodal integration, and the intention, desires, and the consciousness, and the social relationships, right? So intelligence, right? So deep learning, it's wonderful, and the deep learning could change the robotics and AI very much. But however, the deep learning is very much different from the human intelligence, right? And the human brain is more complicated, and and basically we don't need to have a huge amount of data to run something, right? That we can quickly run with a small number of data. So that is a serious difference. And after this, we need to deeply study about the human intelligence and embodiment. So last session, I think you guys were talking about the the issues for the embodiment. So why the robot need to have a body properties? Without the body properties, I think we cannot develop the intelligent robots, right? So body is very important. And then, the multimodal integrations. So far, we just focus on the image, visions, and in auditions and tactile sensations, right? Individually, but the humans, they run and the human understanding the environment by using the multimodal information simultaneously. That and then the human, we can quickly run the complicated things. So we need to develop that kind of multimodal integration functions for the robots. And then the intention desired. I think this is very, very important for make the robot autonomous, right? So we are expecting to have autonomous robots in the near future, but in order to give autonomy to the robots, we have to give intention and desire in some sense, right? And then the ones we can, we give an intention desire to the robot. So I think there is a possibility that we may feel the consciousness through the interaction with that robot, and then we may have more better relationships with the robot, right? So that is the social relationships. So, and on the other hand, we are sharing the roadmap for the robot development in our research group. So now we are focusing on the very practical order taking robot at the restaurants and language teacher robots, and the conversational robots for the elderly and the children. And after this, we're gonna improve the robot more, and we're gonna give a more human-like function to the robot, and we hope to reach to the companion robot, which has the multiple human-like functions, and that can support our daily life. Okay, so these are examples. Okay, we are working with the private companies and for the field test with these robots, and I think that these robots are almost almost practical. And of course, we need to solve the many difficult issues for developing the commercial product. So we need to have more robust robot hardwares, and we need to have more varieties for the variety for the topics a robot can speak, right? But um, the companies, our collaborators, they are very serious to develop these commercial product, and this is already, the commercial product, and we have a venture company for this. Right? Okay, so this is the relation between science and development. So intelligence, embodiment, multimodal integration, these are fundamentals. And once we integrate the intention desire to the robot, I think a robot will be very human-like, and someday we may develop the companion robots that can pass the multimodal Turing test. I want to say, right? So we want a challenge to the total Turing test, but the total Turing test is it's so hard, right? Therefore, we are sharing the this ideas, this multimodal Turing test, as our scientific and engineering goal. So multimodal Turing test is to compare between robots manipulated by human operators and the autonomous robots controlled by developed technology. And one of the important challenges in intelligent robots is to pass the multimodal Turing test, I believe, and it evaluates the total human likeness through the all modalities, and it evaluates the social acceptance as a member of a society, right? So look at this robot. This robot is not, the human-like robot, but it looks a kind of a human, so a small child, right? So so it's easy to distinguish this robot and humans. This is not humans. We can say that, but right. So if the interlocutors they couldn't distinguish if robot operated by human operators or the computers, right? So the robot can pass the multimodal Turing test. So this is our goal, right? So but basically the humans, we have a huge varieties about the appearance, and and the robot, we can, and then we can accept various kind of a robot, from the mechanical looking robot to the human, very human like robots. So therefore, I think, the appearance is not so important to accept the robot as a member of a society, right? I'm studying about the very human like robot android, but on the other hand, I'm thinking like this. So let me introduce the conversational autonomous Android we have developed in our previous project, Erato. So Erato is one of the biggest scientific research found in Japan, and I have worked with professors from Kyoto universities and ATR, the researchers from ATRs, and our challenge was to tackle these fundamental issues. Okay. And consciousness, intention, desires, and intelligence or something, right? Of course, we cannot solve this problem, right? But I think we could do some related works for these fundamental issues. So most important challenge was to implement the intention, desire to the robot, right? Because we wanted develop the autonomous conversational Android, right? So we consider the intention, desire, that causes the emotions and the consciousness of the robot. This, right, and the robot, they can be really human-like with the intention, desires. If we look at the architectures of a human, I mean, the human intention, desire, that is a very complicated. So for the young infant cannot understand own intention, the desires, right? Everything's embedded in the reactive behaviors, right? But after growing, it may be the if I don't know exact age, but after growing, we humans, we can understand that we have basic desires. Then that we can have a concept of a desires. The desires coming to the concept levels, and the desires uh, will choose will choose the intentions to satisfy that, and the intentions will choose the behaviors for satisfying that intentions. Okay, so if we look at the adult, the adult, and so our purpose is to develop the adult Android. Therefore, we are ignoring the human developmental process, but just focusing on the adult, on the mechanism to use the intention, desires, right? So well, that means we are uh, uh, we're using a very simplified architectures for the intention and desires. Desires decide the intention decide the behaviors, right? So um, we have developed this kind of a very simplified hierarchical model for that, right? And of course, that we need to prepare, in order to develop the autonomous Android, we need to prepare the many functions, many sensors, sensors for the position recognitions, audio localizations, facial recognition, something, right? And we need to have main functions for the Android, and um, to process the information coming from the sensor, and motor control, something, right? So the one of our original the software is interaction composers. So in order to develop the complicated Android program, so we have you know we are using this graphical editors for the behaviors. This graphical editor called the interaction composers, and this one they developed in ATR. Okay, so and in addition to the system, so main systems, we need to have many subsystems. So this is the most important subsystem for the Android. Now Android is speaking, right? But here, what we are doing is we are analyzing the voice and the generating lip movement, head movement, and the body movement and the gestures, everything's right. So we are modeling the relationships between the voice and the body movements, and we applying that computer program for generating the natural human-like behavior to the Android. So it's quite troublesome to carefully control the Android movement. So therefore, we have developed uh, these functions so that can generate the necessary human-like movement by analyzing the voice. Okay. So anyway, this is a very convenient
ご飯を食べに行こうっていう話
program.
になって、でどこ
And
に行こうか結構迷ったんですけど、まあ、結局カレーを食べました。
so Android said, well, interlocutor said, I ate a curry, and the Android asked what kind of a curry. So this is the function of attentive listening. So, and developed by Professor Kawahara from Kyoto University, right? So Android, unfortunately, the Android can well, and we cannot expect the perfect voice recognition functions for the Android. Android sometimes cannot understand the voice of interlocutors. In such case, the Android use this attentive listening functions. Actually, Android is not recognizing the human voice, and Android is just well, detecting the end of a voice and detecting the keyword, right, and just rephrasing, right. So without the exact understanding of the voice, Android can continue the conversation by using this, attentive listening functions. This is very important.
ただ、はい、その勉強って本当に必要なのかなって思うんです。いや、絶対に必要になる部分は結構出てくるとは思います。先に話していいですか？
I think you understand what happened here. This is the error recovery function, right? So, this kind of function is very, very important for natural and smooth conversations. Okay, and then finally we have implemented this in desires, right? We have tried the many kind of desires, and we have rebuilt this Android system to maybe at least 3 or 4 times. And finally, we reach to these two basically desires. One is the personal desires for building the relationships with others, and another desire, the social desires, for qualifying the relationships with others, right? So based on these personal and social desires, Android is choosing the intentions, and intentions that these intentions are choosing the the behaviors. Okay. And this is architecture, a little bit more detailed architectures of the Android, right? So, well, I don't explain the details, but I want to just say this is so complicated that consists of many functions, and this is this is a decision-making system, right? And Android is, according to this, these modules and architectures, and Android is choosing the topics and speech sequences, right? So actually, the Android, our Android has the mainly the 5 states, right? For the state of transition of conversations. So, and if nothing happens, and Android is taking the idle state, and then someone they coming to talk with the Android, the state moving to the initial talk state, and then well, they could, if Android and interlocutors could start the initial talk, and then they're gonna have more deeper conversations. It's a dialogue, right? And you know, the interlocutor may ask the different questions by ignoring the context and the dialogue, right? And in such cases, you know, Android moving into the exception state and the answer to the question. Right? So anyway, and under Android, during the conversations, Android update the internal states, and you know. I'm gonna show you the example of internal states later. Okay. And this is topics we have prepared. And this is just a conceptual graph, right? So we are mapping the topics according to the categories of topics. Okay. And you know, the purple dot is the topics for the initial talk, and the orange is the topics for the dialogue. Right? And this is an actual example. We have implemented 150 topics for the Android systems, right? So we are limiting the situations, and the purpose of the Android. Android is sitting in the front of a lobby of our research institute, ATR, always sitting just next of reception desk, and you know, talking with the visitors, right? And Android role is talk with the visitors. Okay, so usually we do not have a deep conversation with visitors, right? We want to talk about just the general things like weathers and the location or something, right? So we have implemented 150 topics for for that kind of a conversational service. Okay. And this is the initial talk, and this is the dialogue. Okay, and this is the real example how the Android was changing the topics. Okay, so in the beginning, Android was choosing the topics from an initial state, and then you know, Android was choosing these more. These topics in a dialogue state. Okay, so and then this is the Android we have developed, and the voice is synthesized, and everything is synthesized. I think you know, this Android is the most human-like Android, and so usually, you know, the visitors, they can talk 5 to 10 minutes about just the general things, and you know, and we a couple of months ago, we have invited the 10 subjects. So you know, it's quite difficult to have the controlled experiment, but you know, that we have invited the 10 subjects, and you know, we carefully check their response, their opinions, right? And you know, the interesting things was 3 of the subjects, they said, "Oh, this Android is controlled by human operators," right? You know, they didn't believe that this Android is controlled by a computer. So that means that, you know, the Android could pass the multimodal Turing test for the 3 people. You know, of course, that is not enough. That we need to improve more and more. But you know, it was a very, I think, you know, it was good for us. And this video shows you how the internal state changes. Okay, so Android is simulating the own mood and the likeness about the interlocutors. And the blue graph is the Android simulated mood and likeness, and the red graph is the interlocutor's mood and likeness. Android is guessing the interlocutor's mood and interlocutor's likeness to the Android by recognizing the facial expressions, by analyzing the talking patterns. And okay, So, and then, the Android, if Android think that, the relationships between Android and interlocutor is getting better and better, the Android will propose to talk about the kind of personal things, right? So, but if interlocutor is not so excited, and if interlocutor doesn't speak, and Android stop to speak, and they're gonna have a very negative atmosphere for that. Okay, one more time, I wanna show you the Android video.
出身は奈
So,
良県です。
sorry, we Android cannot speak in English, but so this the Japanese conversation is quite natural.
関西弁ですか？
Maybe.
あ、私関西弁です。
じゃあ、やっぱり関西弁の男性の方
So
が
anyway, so important things is the interlocutors and visitors could feel their kind of emotion through the conversation with Android, and many people they could feel that kind of their consciousness and intelligence. All right. So after this, I think so it is not so easy to understand these things, but so I think we can grab a kind of a hint, from this the autonomous conversational Android system. Okay. So, and we want to improve the Android system more, and we want to, deeply study about these things. I want to talk one more interesting challenge in our group, right? We are improving the Androids in many ways, and one of the challenges is to build the social relationships with humans, right? So Android is building a social relationships through the conversation. Okay, so how we can do that, right? So, and this is the Android. This is the interlocutors. Okay, and the Android is maintains the model of similarities of object, and the model of preference. Okay, and Android is trying to guess the interlocutors, humans similarity model and the preference model, right? So and especially the similarity. If we use the similarity models, we can the Android and they can guess, can estimate the interlocutors, the preference models efficiently, right? So, and in addition to that, if Android could build the preference model of the interlocutors, so Android can compare the humans, who is similar to whom, right? Okay, so suppose the Android could talk with the 3 people, right? And then and the Android can talk and can have a conversation with the 4th people and say, so you are similar to for example, the person A and person B, right? So that kind of a conversation is very effective for having for developing the good relationships, right? So probably the purpose of the conversation is to establish the social relationships, okay? And in order to have the social relationships in Android and maybe the human interlocutors, they need to develop the own preference model and similarity model, the own similarity model and preference model, and they need to guess the others' preference model and similarity models. Okay, so this is the example. This is the Android similarity models, and well, in this case, Android is the topics is about the Japanese temple, right? So Android is comparing the several temples here, right, and developing the table, and this is the preference tables. Well, in this case, this is the Kiyomizu temple. The Android doesn't like atmosphere, but the Android likes the landscape, right? So, and then through the conversations, and the Android try to develop and try to estimate the interlocutor's preference table and the similarity table, right? So in order to fill up this matrix, the Android asking the question, or Android is comparing the other people's preference tables and the similarity tables. Okay. So this is the example.
そうですね、雰囲気は好きです。
好きなんですね。ですね、京都の伏見稲荷大社の雰囲気は好きですか？
好きです。
好きなんですね。もし
Okay. So Android is asking the questions, and the Android quickly the judging the who is similar to whom, right? And Android is talking about that kind of human relationships. So this is quite effective for making the Android the human-like, and people can feel the a kind of the social relationships with Android. Okay. So then I want to talk about the current challenge. So our current challenge is to develop the robots that can be accepted by the societies. So I have introduced our human adult, the female Android, but when we develop if we develop the adult Android, the people, we need to give adult level conversational function to the Android. So that is so difficult. So, but if we develop the child-like Android like this, we don't need to give intelligent function. The child Android, they can move around, and I think there is one more videos. Okay? So this is a movable Android, and for the adult Android, we are using a pneumatic actuator, but in this case, we are using the DC servo motors. Without noise, very silent, very smooth, the DC servo motors with low gear ratio. So the child-like appearance is quite important, because the people is going to be very kind for the Android, and Android can ask any kind of questions, and Android can gather the information in real societies. So, and we call this approach in social developmental robotics, right? So anyway, so this is our new challenge, and by using these robots, I hope to develop the future society that's supported by humanoid and androids. Okay, so I think I have another 5 minutes, and I want to quickly introduce our next big project. It's called the Moonshot, right? The purpose is to realize a society in which human beings can be freed from a limitation of body, brains, space, and times by 2050, right? So this is a bit ambitious goal, right? But this goal is set by a government, right? And my role is to realize the avatar symbiotic society where everyone can perform the active role without constraints. So I don't read this sentence, but they simply said, I want to develop the intelligent avatars, which can be used by any kind of people. So I have started my Android project, with the teleoperated functions. Right? In the beginning, we were operating the robots, the androids, through the internet. Okay, and this is also the another teleoperation robots. Okay, And the important things, the important feature of this teleoperated Android was, the operator could accept this Android body as his or her own bodies. We could adapt to the mechanical body by operating the Android, right? So we have proved how the operators' brains connected to the Android bodies, right, by using a brain-machine interface. And we have proved that we could have mutual connections, the operator's brain and Android bodies. So if the operator think about the body movement, so such as the left hand move the left hand or move the right hand, right? So and the operator could move the left or right hand. They're just thinking, right? And but in order to control the Android, the operator need to have a 30 minutes training. But before the 30 minutes training, maybe the 10 minutes, just after 10 minutes, and if we move the Android arm and the Android arms, the operator's brain signal quickly they're separated for the right hand pattern or left hand pattern. So when we think, by thinking, we can move the bodies. But if the body moves, our brain activities, the adapting to the body movement, right? So that kind of things happens with this teleoperated robot system. Okay, so that is the possibility of the teleoperated robots. So in this project, we're gonna extend that the studies more and more and develop this kind of future societies. So under the coronavirus situations, many people are staying at home and studying at home and working at home, right? So probably we're gonna keep this kind of the working style, lifestyle, and after the coronavirus, right? So. But I think this kind of a video conference like a Zoom is not so convenient, right? So maybe the avatars, teleoperated robot is much better, right? So by using a teleoperated robot, we can support the student and we can support the home workers and for example, and this is a more important application for the medical applications. The medical doctor can visit the patient home and and can check the healthy conditions. Right? So we hope to develop this kind of the avatar systems and within 30 years. So our project is a 5 years project, but I think that we can develop something for that kind of our futures, right? So our futures that. So I think I need to stop to talk here, and I hope you could enjoy my talk, and I want to accept your questions.
Okay, Hiroshi, thank you very much. This was really, really forward-looking presentations, and there are lots of interesting fundamental questions. So I'm pretty sure lots of questions coming up in the next seconds and minutes. I just want to start off a couple of questions from my side based on our discussions in the last couple of days. So first of all, I'm just curious about your views on information world and the physical world, right? So you have all this learning and the interaction, the reasoning and all this rather conventional way of processing information, or maybe I'm misunderstanding. But I think more importantly, the physical, interaction, the physical entity in the of the robot and the information processing are put together somehow, but they're not influencing each other as we expect from embodied agents. Do you actually agree on this kind of view? Or how do you see the interaction between information processes and physical processes?
Sorry, I didn't know that discussions about that. Could you? I cannot clearly catch your point. Could you explain a little bit more? Sorry.
Yeah, absolutely. So, so you have a sensors, cameras and other sensors, auditory, microphone, and
Right.
and so on. And then you have apply all the signal processing or machine learning, deep learning, all these, processes integrated to your Android systems. Android is the physical system, right?
Right.
And I had the kind of impression that all this learning, information process learning, and decision making are kind of plug into physical systems, but they're not influencing to each other as we expect from an embodied intelligence system. How. For example, self-motivation or the intrinsic motivation comes from your body, but all these processes are kind of given by human designers.
I see. Okay, I understand. So that is a very deep question. Wow. I see. So, well, I think the robot. Well, but you guys, you believe that kind of things happens for the human bodies, right?
That's right. Yes.
And if we carefully design the robots, and in our case in Android, we are designing the internal states, and we are carefully designing the how the robot can update the internal states through the experience and through the based on the sensory information, based on the actions, right? We are all carefully designing the ERICAs, and this is the autonomous and the conversational Android. So and it is pre-programmed, but this is also another approach, without using the deep learning, without using the complicated system. So we can build up the very complicated systems that is similar to the humans. So my approach is I'm focusing on the interactions. So I don't care so much about the similarity of internal mechanism to the humans. Right. The most important thing is to have the human and human-like interaction with a robot, and then I think the robot can be a kind of the social partners, right? So that is my stance and my approach, right? So
absolutely. No, so thank you for the comment. I fully understand your approach, and I think that's a really, really interesting how we can think of embodied interactions in different terms. Another aspect. Go ahead.
But
yes.
on the other hand, I really think the body properties and the human-like intelligence is quite important, right? In order to have the good interactive system, the robot need to simulate the human-like intelligence and but my point is that we cannot we don't need to have a perfect copy of humans, right? So if we can find some essence for that, right? I think that's gonna be enough, right? So I don't care care about the difference of materials. I don't care about the the detail of the systems, but I think if we can find some essence of that, right? Essence of a consciousness, body properties, the multimodal integrations, I think we can develop the human-like robots. Sorry that. So.
Oh, that's fine. Yeah, thank you. And another question I had. Sorry to dominate my question here, but it was. You said something about the appearance is very important for social interaction. And we also had a discussion with Takashi Kigami yesterday about importance of physical interactions, like touch and feels through physical contact. Do you actually see this dimension of the roles of embodiment in terms of social interaction through physical contacts? And have you explored this dimension as well?
Yes, and tactile sensations are quite important, especially for the elderly people. Well, in this case, I think I want to show you this example. Through the tactile sensations, that she could feel the human-like existence, right? So, and a tactile sensation, they encourage the interlocutor's imaginations and very much, and this is quite important. I mean, so if we want to have a good relationships with the humans, so we should use the tactile sensations also, right? So, but even if we don't have a tactile sensation, of course, that we can have good relationships, right? But at least I think the computer, when we're always comparing the computer graphics agent, the computer and the physical robots. So always robot is better because we can exist in the same world, same environment, right? So even if we don't touch to the beautiful Android, it's better to have the Android in the front of us, right? So, if we in the same environment, then we can have a much better the conversation in some sense.
Yeah, thank you. We just had a discussion until yesterday, how important physical interaction is, and it's actually the holy grail of soft robotics, how we can solve better physical interactions between robots and the world. Right. So we got lots of questions in terms of ethics of your research, and probably this is a popular question to your research, but do you want to react anything about ethics of your research? Like what's the boundary, what you think about it?
Okay. Well, where is the questions?
You can open a chat. Don't worry about this. I think you can just speak what you think.
But probably I cannot answer to all questions. But my point. Well, ethics. Yes. Let me talk about the some ethics, right? So it's quite important topic for us, right? But the most important thing is what ethics is. Ethics is kind of the current agreement about our life, right? So it's a kind of average opinions of the current societies, right? So if we exactly follow the ethical things, and we cannot change this world, right? Because we are sharing, and the ethics, we are deciding the ethical, how can I say that? The rules or morals, based on the current societies. Okay, so it is not based on the future societies. Okay, therefore, if we follow if we exactly follow the ethics, we cannot develop the new things, right? The more important things is we need to have a concrete imagination about the futures, how our technology changes our life. Okay, and then we need to have we need to think about the ethics in that situations, not current situations. Okay, so we should not evaluate the technology, future technologies based on the current ethics, right? So we need to have the power. We need to have an imagination about the future ethics, right? Otherwise, we cannot change this world. Again, we cannot develop the new technologies.
Yeah, I think that's a very motivating statement to many of the researchers doing crazy things. And thank you very much, Hiroshi. I think this is a wonderful conclusion of this workshop. And I just want you to stay a few